So we have another topic which is material transport system or material handling, whatever we have discussed in the previous one. There is a significant usage of this material transport system. So there is a definition also which is used for movement, storage, protection and control of materials throughout the manufacturing and distribution process, including their consumption as well as the disposal of particular material. And now we'll see how this is material like transportation is managed. So there are number of transport equipments. As you know, this is a carrier vehicle where you can carry that particular uh, like movement with the wheels. And here, as you can see, the pulley lever, normally called, these are arranged into the pallets. Pallets are nothing but the units where you can arrange this particular move like work part. So next to that, like as you can see, these many AGVs or like autonomous guided vehicles, they can carry the vehicle like materials in the form of pallets. So pallets are nothing but the units of the components which are arranged in one similar box, which is having some unique dimensional systematic dimensional authenticity, so that you can keep that in system of units that you can see how it is arranged in the future slides. So here the help of dry vehicles, and these are the trailer carts which are attached to this particular vehicle, and the vehicle is moving on its own with the help of sensors, and there is no driver, so autonomously it is driving. Normally we call as autonomous guided vehicles. In the same way, these can be used. These are the two wheels, and it is having the driver power which is moving ahead. Monorails, as similar to the trains or the vehicles what we saw. As you can see here, these are the wheels aided particular vehicles where you can use it in a unidirectional, so that you can't change the movement of that particular rail or moving rail guided vehicle, so it will move only in that particular direction and be useful for carrying more heavy vehicles and all. And these are the conveyors on roll. All these particular parts which can roll on this will be used. And here we have skate vehicles. The same way, the rolling, it will be skated like slipped over that particular top, and this is a belt drive, and this is the cart which will be used or transported using that, and pin is for braking. And yeah, these are many material handling system. We have cranes and pulleys on hoists. These all are, I think, you might be seeing in any industries for material handling or transportation. So we have basically the analysis of material transportation. So by we have some assumptions which are nothing but the vehicle is moving through a constant velocity throughout its operation of moving the vehicle, and we are ignoring the effects of acceleration, deceleration and other speeds that might depend on whether the vehicle is traveling with a loaded or empty for other reasons, because all these will be being carried. So all by ignoring all these assumptions, we are making or analyzing the particular material handling transport system. So these are the typical parameters for operation of vehicle based transport: loading at the pickup station, and traveling time for the drop off station after loading, and unloading at the drop off station, and empty travel of the time vehicle between the deliveries. So again, after delivering or dropping off the material, it will come back. All these are the cycle of operations for unloading or taking that particular material handling system into consideration. And this is a system, sorry, this is a formula where you are going to consider, which is for delivery time. This delivery time will be anyway, you just go through it, like it is easy. Only the TEL all are described over here. So the available time is the one which is important. We all make standard available time as 60 minutes by adjusting A, and TF and E, that is like 80 is the available time which we are making it to 60 minutes per vehicles, and A is the availability, and F is the traffic factor, what traffic it's going to actually have in that particular industry, and EW is the worker efficiency. All these two like factors are affecting this particular available time, and we are making that particular available time to be adjusted to 60 minutes by adjusting this availability, traffic factor and the worker efficiency. And the rate of deliveries per vehicles will also be calculated using this available time available time, and TC, the delivery cycle of the time, computed by initial equation, which in the form of minutes and deliveries, and 80 is the available time in 1 hour with adjustments for time losses. So using this, we are going to calculate the rate of deliveries per each vehicle. So the workload, and as the same thing like we did for FMS or bottleneck operation, we are having this workload in this particular material handling system defined as a total amount of work expressed in terms of time that must be accomplished by the material transport system in 1 hour. So within 1 hour, the amount of work or the amount of time which is expressed to accomplish the material transport system in 1 hour. Normally, the workload is given as RF into TC. RF is the specified flow rate of total deliveries per hour. So normally, this workload is nothing but how many like deliveries are happening per vehicle using this particular delivery cycle time. All this together, we can calculate the work. So as previous slides, we can calculate the number of vehicles required to accomplish this workload, like how many deliveries can happen using this particular thing. So determining the number of vehicles in an AGV as required. So yeah, so this is the sample blueprint of autonomous storage or else material handling system. As you can see, the units are placed over here. Normally these kind of arrangement we call as palletization, and this palletization is used for automatic retrieval and storage system. So normally we call as automated storage and retrieval system, where you can store at the same time retrieve that particular one with speed and accuracy under a degree of like defined limited degree of automation. So here, as I said before, these are the pallet loads. All these units are nothing but we call it as pallet loads. On come together grouply, we call it palletization. And we have the storage structures which are in the form of rack, and this is SR mission, which is storage and retrieval mission, which goes here like a floors. It will travel, and it by selecting by giving each individual unit as a time, we can retrieve that by going inside. It can travel inside also like this, and it will go to each and every unit. In that way, it is reachable for each unit in that particular pallet. So here it is arranged in this way, like a support beam, and here we have upright beam, and we have pallet load which is placing on that particular beams. So in that way it is arranged in a unit, and it is very useful in retrieving and storing, and we have a track of each and every individual item where we can easily retrieve or store for that particular use. So these are the uses, like you can go through it. It's like how and what, and we have components also for this storage structure. Example, as I showed, pallets, and we have the particular arrangements like components and terminology. As you can see, it is self-explanatory. This is rack width, row, ASL, and these are the ASL units, and this is the storage space of that particular pallet, and the stack for moving that we call as clearance for PID area, and this is a generic structure. So based on this, I'm not giving much weightage to this, but anyway, you can go through this and understand. It's not having even the definitions are there with this particular diagram. You can go through it and understand it. So basically we have this capacity per SL. SL is nothing but the distance between one particular rack and the first rack in the second row. So there are capacity. How much capacity is decided by using this particular formula, where N is the number of load compartments along the length of the ASL, and this is through the height. So based on the length and height, we need to define how much capacity that ASL is having. So these two factors or these two parameters are useful for calculating that, and individual storage space dimension also will be calculated using WLH, which is nothing but the height of the rack, length and width of the rack, and LBH or the unit load. Unit load is the one, the pallet unit or the component unit, which is very small, and the depth of that also. All these culminating will be useful for designing that particular space dimensions of the storage of the pallet. So this one example, the simple thing, like everything is given in the example, the length and height and width. Just simply substituting that, you will get the capacity of the storage per cell. And these are some like simple formula for, anyway I'm not going to ask in this exam, but just for your idea, you go through it, and just how these are manipulated or arranged, you have to understand that. So here I have given some like formula which is already used before. So in this way we are going to design and analyze that particular material handling system for palletization and retrieval. Yeah, thank you.